Very good morning, students. In the last class we are completing chemical properties of carbon family. Today we are discussing anomalous behavior of carbon. Anomalous means special behavior, peculiar behavior. The element carbon is having anomalous behavior when compared to the rest of elements present in the same group. Because of following reasons: carbon is having small size, highest electronegativity, highest ionization energy, and absence of vacant d orbital. Due to these four reasons, the carbon is having some anomalous properties when compared to rest of element, even though they are belongs to same group. The first property is carbon maximum covalency is 4. That is, combined capacity is 4 due to absence of vacant d orbital. Here d orbitals are absent, hence maximum covalency will be 4. And the carbon contains only 4 valency orbital. What are they? 2s and 2p. 2s contain 1 valency orbital, 2p contains 3 valency orbital, total 4 valency orbital. There is no d orbitals, hence the maximum covalency will be 4. Whereas the rest of elements, that is silicon, germanium, tin and lead, covalency will be more than 4 or greater than 4, because due to presence of vacant d orbital, silicon contains 3d, germanium 4d, tin and lead contains vacant d orbital. Due to presence of vacant d orbitals, the covalency will be more than 4. Due to these reasons only, silicon can form silicon hexafluoride, germanium can form germanium hexachloride, but carbon does not form carbon hexachloride. This compound is not formed because absence of d orbitals in carbon, presence of d orbitals in the rest of the elements. In PU board point of view, for 2 marks question they will ask like this: see, carbon hexachloride does not form, but silicon hexafluoride is formed. Justify your answer. Simple reason: absence of d orbitals in carbon, presence of d orbitals in silicon, sufficient. And these hexa compounds are having sp3d2 hybridization, like sulfur hexafluoride. Always hexa compounds are having sp3d2 hybridization and octahedral shape. That is the first anomalous property. Second one, the carbon tetrachloride does not undergo hydrolysis due to absence of vacant d orbital, whereas the chlorides of the rest of elements, silicon, germanium, tin and lead, upon hydrolysis they can form compounds. Previously we are discussing silicon tetrachloride upon hydrolysis to form silicon tetrahydroxide, which is known as silicic acid. For example, silicic acid, because in the case of carbon tetrachloride, absence of d orbital and rest of elements presence of vacant d orbital. Silicon tetrachloride upon hydrolysis it can form silicic acid. It is the second anomalous behavior property. Third one, student, carbon can form p-pi multiple bond with itself and other elements of the similar electronegativity. Because in carbon there is no d orbital, hence only p-pi multiple bond is present. Whereas rest of elements can form other type of bonding, that is d-pi-p-pi bond as well as d-pi-d-pi bond. In the case of the rest of elements, that is silicon, germanium, tin and lead, d-pi-p-pi as well as d-pi-d-pi bonding is possible, because where vacant d orbital absent in carbon, vacant d orbitals are present in the rest of the elements. Here carbon can form p-pi multiple bond with itself and other elements of the similar size and same electronegativity. For example, carbon double bond carbon, carbon triple bond carbon, carbon double bond N, carbon and nitrogen nearly same size. carbon triple bond N, carbon double bond oxygen. Oxygen and carbon nearly same size and electronegativity, and carbon triple bond oxygen. Therefore, the p-pi multiple bond formed between carbon itself and other elements of similar size and nearly same electronegativity. Whereas the rest of elements can form d-pi p-pi bond and d-pi d-pi bond. This in detail we are discussing in the introduction, and the strength of these 3 pi bonds also we are discussing. P-pi p-pi bond more strong than p-pi d-pi bond, which is more strong than d-pi d-pi bond. Once again verify the previous video student. Next one, the carbon is having highest catenation capacity when compared to the rest of the elements, because CC bond is very strong and carbon is having tetravalency. In organic chemistry we know that catenation, the phenomenon of self-linking of atoms to form long chain and big rings, are known as catenation capacity. Due to this catenation capacity only, carbon can form alkanes, alkynes and aromatic hydrocarbons, contains 5 carbon chain, 10 carbon chain, decane, undecane. The reason is catenation only. The reason will be catenation only. The catenation is the reasons for catenation will be like this. Carbon is having highest catenation capacity when compared to the rest of the elements, because CC bond is very strong. When carbon bond is formed, the bond will be very strong. Second one is carbon is having tetravalency. Carbon is ready to form 4 bonds, with other elements. Due to these 2 reasons, the carbon is having highest catenation capacity. The catenation capacity of group 14 elements follows the following order. Carbon is very much greater than silicon, silicon greater than germanium. Germanium and tin are nearly similar catenation capacity, and lead does not show catenation property. Because the CC lead bond energy will be very less. Hence, lead does not show catenation capacity. In examination point of view, they will ask, name the element which does not show catenation property. Lead. Because the lead bond will be very weak, does not show catenation property. Here student, here some experimental values are given. The CC bond strength is 348 kilojoule. That is the bond strength or bond energy. The amount of energy is required to break the bond are known as bond energy. As the bond energy increases, bond strength increases. Here CC bond is having more bond energy than silicon, than germanium and tin. Here more bond strength, more bond energy, hence highest catenation capacity. Less bond strength, less bond energy, and hence it is less catenation capacity. Here the bond energy values are nearly same, hence the catenation capacity also nearly same. Okay students, with this anomalous behavior of the carbon will be completed. Copy this. Okay, next continuation students, anomalous behavior of carbon is completed. Now very important topic, that is allotropy. What is meant by allotropy? The phenomenon of existence of same element in more than one form are known as allotropy, and different forms are called allotropic forms, The phenomenon of existence of same element in more than one form are known as allotropic form. In this topic we are discussing allotropic forms of carbon. Carbon can exhibit 2 types of allotropic forms. There are crystalline allotropic forms and amorphous allotropic forms. The crystalline means that is solid substance which is rough in nature, like sand. Amorphous allotropic form is powder. We are using powder, that is smoothness powder form. Rough sand like a crystalline, smooth powder means amorphous. The crystalline allotropic forms of carbon is of 3 types: diamond, graphite, fullerene. And amorphous allotropic forms of carbon black and charcoal. Now, in examination point of view, based on this NEET exam, one question is given. What are the 2 reasons to exhibit carbon allotropic forms. Okay, carbon can exhibit allotropy, well and good. Why carbon can exhibit allotropic forms? Because of two reasons, student. One is carbon is having highest catenation capacity in the periodic table. Carbon is able to form p-pi multiple bond with itself and other elements of same size and similar electronegativity. Whereas silicon, germanium, tin, lead are not having these two properties, hence they does not, even they can exhibit allotropy, they are not having that much importance. Therefore, the allotropic forms of carbon are important. The carbon can exhibit allotropy because of two reasons. These are, carbon is having highest catenation capacity and carbon is able to form p-pi multiple bond with itself and other atoms of similar electronegativity. Okay, students. Next one, diamond. We are discussing one by one. Diamond, graphite, fullerene, carbon black and charcoal. First allotropic form is diamond, which are used in jewelry, very famous diamonds. Here some points, students, we are discussing one by one. First one, in diamond, each carbon atom is bonded to the 4 other carbon atoms in a tetrahedral manner to form 3-dimensional network structure. In diamond, only carbon atoms are present. Black carbon atoms are present. Each carbon atom can be bonded to the 4 other carbon atoms in a tetrahedral manner. 4 other carbon atoms in a tetrahedral manner, like these, students. In diamond, each carbon atom, that is each carbon atom, can be bonded to the 4 other carbon atoms in a tetrahedral manner. Next point. Yes, a similar point. In diamond, each carbon atom is bonded to the 4 other carbon atoms in a tetrahedral manner to form 3-dimensional network structure. That is, this structure is bonded to another 2 more structures. Like this 3-dimensional network structure is formed. 3-dimensional network structure will be formed. Second point. In diamond, each carbon atom can undergo sp3 hybridization and the carbon-carbon bond length is 154 picometer. Here around carbon, 4 sigma bonds are present by using 4 carbon atoms. Hence the hybridization is how, what is, student? sp3 is the hybridization. Very important, student. 1 mark, student. What is the hybridization of carbon in diamond? sp3 hybridization. Because carbon atom is surrounded by 4 sigma bond, and Cc bond length in a diamond is 154 picometer. The carbon-carbon bond length between any 2 carbon atoms, how much, students? That is 154 picometers. Second point, student. Third one, diamond is the hardest substance on the earth because strongest and extreme covalent bonding is present between the carbon atom. Diamond is the very hardest substance on the earth because extreme and hardest covalent bonding is present between the carbon atom. We know that, student, one diamond is cut by using another diamond only. One quotation is also, cut the diamond with the diamond only. Why? Because to cut the diamond there is no substance on the earth. Hence diamond only can be, it will be used. That's why that much hardness substance on the earth. What is the reason, student? Because of strongest and extreme covalent bonding present between the carbon atom. In exam they will ask why diamond is hard? Because of strongest and extreme covalent bonding between the carbon atom. We know that the Cc bond energy is 340 kilojoule mole inverse. We are discussing already in a previous topic, anomalous behavior of carbon. The Cc bond is very strong and is having high bond energy, that is 340 kilojoules. Okay, student. Next one. Diamond is having highest melting point because highest temperature is required to break the strong carbon-carbon bond between the carbon atom in a 3-dimensional network solid. We know that diamond is a covalent compound. Diamond is a covalent bond because between the 2 carbon atom covalent bond is formed because both are having similar electronegativity. Even though diamond is having highest melting point, It is opposite to the normal behavior. Generally, ionic compounds are having highest melting point because of strong intermolecular force of attraction between the ion, whereas covalent molecules are having less melting point. But here, even though diamond is covalent in nature, but that is having highest melting point because strongest carbon-carbon covalent bond is present between the two carbon atom in a three-dimensional network structure. In PU board, this question is given, student. Why diamond is having highest melting point even though it is not an ionic compound or covalent compound? Even though it is not ionic compound or it is a covalent compound. Why? Because even though it is a covalent compound, but strong carbon-carbon bond is present between the two carbon atoms in a three-dimensional network structure. Hence, more temperature is required to break the bond between the carbon atom in a molecule. Okay, student. Next one. It is used as abrasive for sharpening hard tools. Generally, the hard tools can be sharpened by using diamond. This property is known as abrasivity. Hence, diamond is used as an abrasive for sharpening hard tools. Next one, student. Diamond is used in the manufacture of tungsten filament in an electric bulbs. Generally, electric bulb contains tungsten filament. Why? Because if you use any aluminum filament or copper filament, that is having lowest melting point. In the electric bulb, once the bulb is glowing, more temperature will be appears in the bulb. More temperature is present in the bulb. With the temperature, the filament is not having highest melting point. That is undergo melt. That's why the tungsten filament is used. That is having a melting point nearly more than 1000 degrees centigrade. Due to this reason, the diamond can use. It is used in the manufacture of tungsten filament in an electric bulb. We know that electric bulb contains tungsten filament. In that tungsten filament, they are adding small amount of the diamond, which increases the melting point of the tungsten filament. Then the tungsten filament used in the electric bulb. Electric bulb is always glowing, hence temperature of the bulb increases. As the temperature of the bulb increases, the filament undergo melt. To prevent the melting of the tungsten filament, they are adding little amount of diamond because diamond is having hardest and highest melting point substance. Therefore, diamond is also used in tungsten filament in electric bulbs. Okay, student. Next one. Diamond is insoluble in organic solvent. Generally, covalent compounds are soluble in organic solvent. Even though diamond is a covalent compound, but that is insoluble in organic solvent because same reason. Strong CC bond is present between the carbon atoms in a diamond. Insoluble in organic solvent. Next one, student. The standard enthalpy of formation of diamond is 1.9 kilojoule mole inverse. The standard enthalpy of formation of diamond is 1.9 kilojoule mole inverse. Why? Because for the formation of 1 mole of diamond, some amount of energy will be released, that is known as enthalpy of formation. The amount of heat energy liberated when 1 mole of diamond is formed are known as enthalpy of formation. That is how much, student? 1.9 kilojoule mole inverse. These are the points regarding diamond, student. Let us observe the rough diagram of the diamond structure. In examination, they are not asked, not important, but roughly in diamond, each carbon atom is bonded to the four other carbon atoms. In a tetrahedral manner to form three-dimensional network structure. Like this, each tetrahedral carbon is bonded to some other carbon atom to form three-dimensional network structure. Since each carbon atom bonded to four carbon atom, hence the hybridization will be sp3 hybridization, and CC bond length will be 154 picometers. Okay, students, like this crystalline structure of the diamond and three-dimensional structure of the diamond. In the NCERT textbook also structure is given, student. Once you can observe. Okay, copy this, student. Okay students, next allotropic form of carbon, that is graphite. That is graphite. Here also some points is there student, we are discussing one by one. The first one is, in graphite each carbon atom is bonded to three other carbon atoms in a trigonal planar manner to form hexagonal rings. In graphite each carbon atom is bonded to three carbon atoms. Each carbon atom is bonded to three carbon atoms in a trigonal planar manner. Like this. In the form of hexagonal rings. The trigonal planar manner arranged with one another to form a hexagonal ring. That is a six-membered ring. Next one student. In graphite each carbon atom undergo sp2 hybridization and CC bond length is 141.5 picometer. Here each carbon atom can undergo sp2 hybridization because this carbon atom is bonded to three other carbon atoms and the carbon-carbon bond length is 141.5 picometers. It has layer structure in which one layer slides on another layer and distance between the layers is 341 picometer. It has a layer structure student, like first layer, second layer, third layer, fourth layer. The graphite is having layer structure in which one layer slides on another. The layers are not constant, always one layer slides on another. At the same time, the distance between any two layers will be 340 picometer. That is, distance between these two layers and these two layers will be how much student? 340 picometer. In examination they will ask student, what is the distance between the layers in graphite? 340 picometer. What is the hybridization of carbon? sp2 hybridization. What is the CC bond length? 141.5 picometer. Next one student. In graphite, on each carbon atom, one electron is present in unhybridized p orbital. This electron forms extensive delocalized pi electron system. We know that carbon is having 4 valency electron like this: 1s2, 2s2, 2p3, 1s2, 2s2, 2p2 student, 2p2. Here, carbon is having 4 valency electron. But in graphite, the carbon can undergo sp2 hybridization. To undergo hybridization, excitation of electron will be required. Hence, by supplying energy, one electron jumps from 2s orbital to 2pz orbital. Hence, the electronic configuration is 1s2, 2s1, 2px1, 2py1, 2pz1. Since carbon atom can undergo sp2 hybridization, one s orbital overlap with 2p orbital to form 3 sp2 hybrid orbital. Hence, they can bond in a trigonal planar manner. But what about this electron? This electron present in unhybridized 2pz orbital. Regarding this electron, this point we are discussing today. That is, on each carbon atom, one electron is present in the unhybridized p orbital. These electrons forms an extensive delocalized pi electron system. That is, this carbon atom contains one electron, like this each carbon atom contains one electron. They can form extensive delocalized pi electron system. Clear student? Right. What is that extensive? Next point we are discussing student. That is, it can act as good conductor of electricity because delocalized electrons are moving across the layer. Here student, on each carbon atom one electron is present. This electron is moving across the layer from first layer to second layer to third layer. Movement of electron takes place. We know that flow of electrons is known as electric current. That is, the unhybridized electron present on each carbon atom moving across the layer. Movement of electron takes place. Therefore, graphite can act as good conductor of electricity. Here one interesting point student. Graphite is a covalent compound. Generally, all the covalent compounds are bad conductor of electricity. Ionic compounds are good conductor of electricity. In differences, ionic compounds are good conductor of electricity. Covalent compounds are bad conductor of electricity. Even though graphite is covalent compound, it can act as good conductor of electricity because of extensive delocalized pi electron system. Because of extensive delocalized pi electron system. That is, student. Graphite acts as good conductor of electricity because delocalized electrons are moving across the layer. That is extensive delocalized pi electron system. The pi electrons, the 2pz electron always moving across the layer, always moving across the layer. Next question. Graphite used as dry lubricant in the machines which are running at high temperature where oils are not used as lubricant. Graphite used as dry lubricant in the machines which are running at a high temperature where oils are not used as the lubricant. Some machines running at high temperature where oils are not used. At the time we are using graphite which can act as dry lubricant because weak van der Waals forces are present between the layers and these layers are slippery and soft in nature. Between the every two graphite layers, weak van der Waals forces are present. These layers are slippery and soft in nature. That is, these layers are sliding one over the other. Due to this reason, they can act as the dry lubricant. Okay, students, in examination they will ask why graphite used as lubricant. Due to presence of weak van der Waals forces between the layers, these layers are soft and slippery in nature. Here I will tell one interesting point, student. For example, the pencils contains graphite. The black color substance, that is lid, is known as graphite. If you write on the paper with a pencil, what happens? The black color line is observed. If you draw a line, the black color line is observed. Why? Because in between the layers in the black color substance in the lid of the pencil, between the layers there is a weak van der Waals forces are present. If you apply pressure, the van der Waals forces are broken, hence the line is formed on the white paper. Once again, in the pencils, the lid nothing but graphite. In the graphite, layer structure is present. Between the layers, weak van der Waals force is present. If we apply pressure on the paper of the pencil, what happens, student? The van der Waals forces are broken. And a black line is formed. Because due to applying pressure on the pencil on the paper, then what happens? The van der Waals forces are broken. That is practically we are observing in our daily life, student. The lid of the pencil nothing but graphite. Lead pencils does not contains lead. Lead pencils contains graphite. Okay, students, right? Next one. The standard enthalpy of formation of graphite is 0. Hence, graphite is thermodynamically most stable allotropic form of carbon. The standard enthalpy of formation, the amount of heat energy released when 1 mole of graphite is formed, are known as standard enthalpy of formation. Here, amount of energy released is 0. As energy is decreases, stability will be increases. The enthalpy of formation decreases, stability will be increases. We know that energy and stability are inversely proportional to each other. Less energy, more stability. More energy, less stability. Both are inversely proportional to each other. Here, standard enthalpy of formation is 0. Hence, that is the most stable allotropic form of carbon. Graphite is the most stable allotropic form of. Repeated question, student, in examination point of view. Name the thermodynamically most stable allotropic form of carbon. Graphite. Graphite is the thermodynamically most stable allotropic form of carbon. Next one, student. Graphite is insoluble in organic solvents. Graphite is a covalent compound, but it is insoluble in organic solvent. The rough diagram of the graphite is like this, student. It is in which the carbon atom is bonded to 3 other carbon atoms in a trigonal planar manner in the form of hexagonal rings. The graphite is having layer structure, one over slide over the other. The distance between the layers is 340 picometer. The distance between the carbon atom is CC bond length is 141.5 picometers. And the carbon atom is having sp2 hybridization. The carbon atom is having sp2 hybridization. Okay, students. In examination point of important is what is hybridization of carbon graphite? Why graphite has lubricant? Why graphite has good conductor of electricity? These 3 points you can remember, students. Copy this.